Example 1. Okay, so part A here, I've got dy by dx equals x to the power of 4. I'm going to write that as 1 times x to the power of 4 and show the coefficient. So to integrate, I'm going to add 1 to my old power to give me my new power of 5, divide my new power into the coefficient, and give x to the new power. And don't forget to add the constant term. Let's look at part B. I've got dy by dx equals x to the power of minus 5. So I'm going to write that as 1x to the power of minus 5 and show my coefficient. I'm going to add 1 to the old power. So my new power is minus 4. Divide my new power into the coefficient and give x to the new power. And don't forget your constant term. Now, of course, looking at this one, you could simplify that to minus a quarter x to the power of minus 4 plus c. Or if you preferred, you could write that as minus 1 over 4x to the power of 4 plus c. And that's example 1. Example 2. Part A here, I've got f dash of x given as 3 times x to the power of a half. So I'm going to integrate that to give me f of x. Right. Add 1 to the old power. So the new power is going to be 3 over 2. Divide the new power into the coefficient and give x to the new power. And don't forget your constant term. So that will simplify now to 2x to the power of 3 over 2 plus your constant term. Right, let's look at part B. Part B, the question is f dash of x equals 3. So that means that f of x is simply 3x, and don't forget your constant term. And there's example 2 done. Example 3. So I've got dy by dx is 6x plus 2 times x to the power of minus 3 times x to the power of a half. So I'm going to integrate that to give me y. So I'm going to add 1 to the power. Remember, this is x to the power 1. So add 1 to the power gives me 2 and divide that into the coefficient. Now add 1 to the power. So that's going to give me minus 2. Divide the new power into the coefficient. Give x to the new power. Minus 3. Add 1 to the power. So that's going to be 3 divided by 3 over 2. X to the power of 3 over 2, and don't forget your constant term. Right, let's see if we can simplify this. Well, 6 over 2 is simply 3x squared, minus x to the power of minus 2, minus, now 3 divided by 1.5 is 2, x to the power of 3 over 2, plus the constant term at the end. And there is the answer to example 3. Example 4. Right, in part A here, we need to integrate x to the power of a half plus 2x cubed. Right, so we will integrate each of those term by term. So the x to the power of a half, that's, you need to think about that as 1 times x to the power of half. So we're going to have the coefficient divided by the new power times by x to the new power plus 2 over, well, the new power is going to be 4, x to the power of 4 plus the constant term. So now let's simplify that. The reciprocal of 3 over 2 is 2/3, x to the power of 3 over 2 plus a half, x to the power of 4 plus c. And that's example A done there. Right, let's look at example B. So the question here is to integrate x to the power of minus 3 over 2 plus 2 with respect to x. Okay, so that's going to give 1 there, isn't it? So the old coefficient divided by the new power. Now minus 3 halves plus 1 is simply minus a half. And then x to the power of the new power plus 2 integrates to 2x, and don't forget your constant term. Right, can we simplify this? Yes, we can. 1 divided by minus a half is minus 2. So minus 2, x to the power of minus a half, plus 2x, plus c. And that is part B done. Right, let's look at part C now. Part C, we've got to integrate p squared. Well, don't worry about that, that's just a constant term. X to the power of minus 2 plus q, another constant term with respect to x. Right, so p squared is just the coefficient of x to the power of minus 2. So I'm going to have the coefficient divided by the new power. Well, the new power, x to the power of minus 2 plus 1 is minus 1, and then x to the new power. Plus, well, q simply integrates to qx, and don't forget your constant term. So this will simplify to minus p squared x to the power of minus 1 plus qx plus c. And now I'm only left with part D. Here we go, part D. We need to integrate 4t squared plus 6, and this time we're integrating with respect to t. All right, so 4 is the coefficient, divide by the new power, 3 times by t cubed, plus 6t, and don't forget your constant term. And that is part D done, and there is example 4 complete. Example 5. Right, let's have a look. In part A, I need to integrate 2 over x cubed minus 3 root x with respect to x. Now I'm going to rewrite that as 2x to the power of minus 3 3x to the power of a half, because then I'll find that easier to integrate. Right, let's integrate 2 times x to the power of minus 3. Now the new power will be minus 3 plus 1 will be minus 2. So the coefficient divided by the new power times x to the new power. Minus, right, the new power will be 3 over 2. So I'm going to have the coefficient divided by the new power times by x to the new power. And don't forget your constant term. Now we can make this look a bit tidier. Minus x to the power of minus 2 minus 3 divided by 3 halves is 2 x to the power of 3 over 2 plus c. Okay, and if you would like to, you can write that as minus 1 over x squared minus 2. Now what would this be? Square root of x cubed plus c. There you are, and I think that that looks pretty good. So that is part A done. Right, part B. Let's copy that here. So this time we've got to integrate x times x squared plus 2 over x with respect to x. Now before I do anything, I'll multiply out that bracket. So actually I'm integrating x cubed plus 2 with respect to x. So that is going to be, remember there's a coefficient of 1 there, so 1 over the new power times x to the new power plus 2x, and don't forget your constant term. And that is part B done. Right, let's look at part C. Let's copy it down here. So part C is, I've got to integrate 2x all squared plus root x plus 5 all over x squared with respect to x. Okay. All right, let's rewrite that, make the whole thing a bit simpler. Well, 2x all squared is 4x squared plus, now I'm going to split this fraction up. So I've got root x over x squared plus 5 over x squared. All right, now I'm not quite ready to integrate this. I'll keep the 4x squared as 4x squared. Now, root x divided by x squared, well that is x to the power of a half divided by x squared, and of course you subtract the indices. So that is simply x to the power of minus 3 over 2 plus 5x to the power of minus 2. So that is now ready for me to integrate it, I think. All right, so Integrating 4 over 3 x cubed plus 1 over minus a half x to the power of minus a half plus 5 over minus 1 x to the power of minus 1. Don't forget your constant term. So that is going to be 4/3 of x cubed minus 2 x to the power of minus a half minus 5 x to the power of minus 1 plus c. Okay, and of course, if you want to, you can write that as 4x cubed over 3 minus 2 over the square root of x minus 5 over x plus c. And that is that example done. And that is example 3, example 5, all complete. Example 6. Okay, so I've got a curve which has an equation y equals f of x. I know it passes through a certain point, and I know that the gradient function of that curve is x squared minus 2 all over root x, and I need to find the equation of the curve. Right, well, first of all, we're going to integrate this f dash of x to find f of x. But before I do that, I'm going to write it into an easier form. So I'm going to split this fraction like that. And I'm going to write it in an easier form still. I'm still not ready to integrate that. So that's x squared divided by x to the power of a half. Subtract those indices. X to the power of 3 over 2 minus 2 x to the power of minus a half. Now I'm ready to integrate that. So f of x will be, there's a 1 there, remember, 1 divided by the new power, x to the new power, minus 2 divided by the new power, x to the new power, don't forget the plus c. All right, let's make this a bit simpler, shall we? So f of x is going to be, the reciprocal of 5 over 2 is 2/5. Now that's x to the power of 5 square rooted, minus, well, that's 4 times the square root of x plus c. Okay, so there's my function, but of course I need to work out what that constant term is going to be if I want to work out the equation of c. And I have a big clue here because I know that the point 4,5 lies on the curve. So I know that f of 4 equals 5. When I stick x equals 4 in, I should get the answer 5. So I know that I can write an equation here. 5 will equal 2/5 times the square root of 4 to the power of 5 minus 4 times the square root of 4 plus c. So that tells me that 5 is equal to, bit of calculator action here, 24 over 5 plus c. So c is equal to 1/5. Right, now I'm in a position to find the equation of c. So that's going to be f of x equals, so 2/5 of the square root of x to the power 5 minus 4 root x, no longer plus c, because I know what c is now. C is 1/5. So there is the equation of c, and that's example 6 done. Okay, example 7. Right, we need to evaluate this definite integral here. So let's just jot it down to start with, and we can have a look at it. So we've got x to the power of 1/3 minus 1 all squared, and we need to differentiate that with respect to, integrate that with respect to x and evaluate the definite integral. Okay, before we get started, let's see if we can simplify this a little bit. So I'm going to write it as x to the power of 1/3 minus 1 multiplied by x to the power of 1/3 minus 1. And now I'm going to multiply out those brackets, expand those brackets. X to the power of 1/3 times x to the power of 1/3, add those indices, x to the power of 2/3. My middle term is minus x to the 1/3, and my outer term is minus x to the 1/3, so I get minus 2 x to the 1/3. Minus 1 times minus 1 is plus 1, and I'm going to still be integrating that with respect to x. Right, I think I'm ready to integrate this now. So remember this is a 1 here, so it's going to be the coefficient divided by the new power. Well, 2/3 plus 1 is 5/3. So it's 1 divided by 5/3 x to the new power minus 2 over 4/3, the new power, times x to the new power, plus 1 simply integrates to give you x. I don't need to worry about the plus c term, and I'm going to evaluate that between 0 and 1. Okay, now let's simplify that still further. The reciprocal of 5/3 is 3/5, so I've got 3/5 x to the power of 5 over 3. Minus, right, 2 divided by 4/3 is 3 over 2, x to the power of 4/3, plus x. And I think now I'm ready to evaluate this between the values of 0 and 1. So first of all, I'm going to substitute x equals 1 in here. Of course, substituting x equals 1 is always pretty straightforward. There we go. And then I'm going to subtract the value of that expression when x equals 0, which actually in this case, each of those terms simply is 0. So that gives me, the first bracket works out at 1/10, and from there, of course, you're minusing nothing at all. So the value of that definite integral there is simply 1/10, and that is example 7 done. Example 8. Right, given that p is a constant and that the definite integral of that expression between 1 and 5 is equal to 4p squared, show there are 2 possible values for p and find these values. Right, well, let's start off by evaluating this definite integral, and then we'll set what we get equal to 4p squared, and I imagine that will give us an equation. So let's start off by copying down this expression here, 2px plus 7. Right, so let's evaluate this definite integral here. So I'm going to integrate this expression here. So I'm going to have 2p is the coefficient divided by the new power. Well, the new power is 2. So my new coefficient will simply be p x squared plus 7x. That's the integral of 7. And of course, I don't need to worry about the plus c. And I'm going to evaluate that between 1 and 5. Right, so let's crack on and evaluate it between 1 and 5. Shall we substitute 5 in for x? I get 25p plus 7 5s are 35. And from that, I'm going to subtract the value of this expression when x is 1. So I'm going to subtract p plus 7. Notice how I'm being careful with my brackets here so I don't mess up my sign. So that's going to be 25p plus 35 minus p minus 7, which is going to equal 25p. No, it's not. It's going to equal 24p, I beg your pardon, plus 28. Right, so that is an expression for the value of that definite integral, and I know that it tells me that the value of that definite integral equals 4p squared. So here is an equation. So I think if I solve this equation, I will get my 2 possible values for p. Let's have a look. Right, I'm going to subtract 24p and subtract 28 from both sides. So I'm going to get 4p squared minus 24p minus 28 equals 0. And now I'm going to factorize the left-hand side. Before I do that, well, I can take out a 4, can't I? So it's going to be 4 lots of p squared minus 6p minus 7 equals 0. And now I can factorize this further. P and p equals 0. What's it going to be? Minus 7 and plus 1. So my solutions to this equation are that p could be minus 1 or 7. Right, let's look at the question. Given that this is true, show that there are 2 possible values for p and find those values. I think we've done that. That's example 8 complete. Example 9. Right, we've got to find the area of the finite region between the curve with that equation and the x-axis. Right, well, let's just sort out what we're being asked to do here. It would be quite useful to have a sketch. So in order to sketch this curve, I'm going to factorize the right-hand side here. So I'm going to have plus x and a minus x to give me the minus x squared. I'm looking to multiply to 20, but I need minus 1x there. So I'm going to have 4 minus x and 5 plus x. And at the end of the day, that would give me minus an x. Yes, it would. Good. So I can see that the roots of this equation are minus 5 and 4. So now I think I can sketch the graph here. Right, so there's my y-axis. Here's my x-axis. Now my graph, I know it goes through 20 here. And I know that it is, let's 2, 4, 5, so it's going to be minus 5 there. And now it goes through 4 here. So it's going to look something like that. Oh, don't think much of that. But anyway, that's what it's going to look like. And I'm being asked to find the area of this region here. So the area under the curve there between the values of minus 5 and 4. All right. Now we understand what we're doing. Let's have a look. So we're going to need to evaluate the definite integral between minus 5 and 4. And our equation is this one. Okay, so that's what we're being asked to do. So let's get on and do it. So I'm going to integrate the expression here. It's going to give me 20x minus, right, remember there's a 1 there, 1 divided by the new power, x squared, minus 1 divided by the new power, and x to the new power. And I'm going to evaluate that between minus 5 and 4. Right, so that is good. Now I'm going to substitute 4 in. 20 times 4 is 80, minus a half of 4 squared, half of 16 is 8, minus a third of 4 cubed, which is 64. And from that, I'm going to subtract the value of the expression when x equals minus 5. 20 times minus 5 is minus 100. Right, minus 5 squared is 25, so minus a half of 25. Okay, and now I'm going to have minus a third multiplied by minus 5 cubed is minus 125. Okay, so that's what I am evaluating there. If I put that carefully into my calculator, I find that the value is 243 over 2. So that is the area of the finite region between the curve and the x-axis. And that's example 9 finished. Example 10. Right, let's have a look at this one. So this time we're asked to find the area of the finite region bounded by the curve, this curve here, and the x-axis. Let's draw a diagram so we can see what's going on. Right. Okay, so this curve has got roots at 0 and at 3. Now, it's got a positive x squared, so it's going to look like this. And we're being asked to find the area of this region here. Now, in this case, the region is below the x-axis, so I'm going to get a negative answer to my definite integral. So I'm going to need to just be aware of that. Right, let's have a go. So I'm being asked to evaluate the definite integral between the values of x equals 0 and x equals 3 of this expression here with respect to x. Okay, so the first thing to do is to multiply out that bracket. So I've got x squared minus 3x, and that's what I'm being asked to do. Right, so let's get on and integrate that. So 1/3 x to the power 3 minus 3 over 2 x squared. I don't need to worry about the constant term, and I'm evaluating it between 0 and 3. Right, stick x is 3 into that expression, so I get 1/3 of 27 minus 3 halves of 9. And from that, I'm subtracting 0 because that's the value of the expression when x equals 0. So that gives me an answer there of minus 9 over 2, or minus 4.5, of course. So remembering that I was expecting a negative answer because I am finding the area underneath the x-axis, the answer to the question here is that the area of the finite region bounded by the curve and the x-axis is 4.5. Of course, it is not a negative 4.5. And that's example 10 finished. Example 11. Right, I'm going to sketch the curve with this equation first of all. So I've got y equals x multiplied by x minus 1, x plus 3. Right, so let's get ourselves a set of axes here. Right, now this equation has got roots when x equals 0, x equals 1, and x equals minus 3. So I'll put that here. Right, and it's a cubic, isn't it, with a positive x cubed. So it's going to look like this. Okay, good. That, by the way, is when x equals minus 3. That's when x equals 0, and that's when x equals 1. Now, there's the curve sketched. I'm being asked to find the area of the finite region bounded by the curve and the x-axis. So I'm being asked to find this region here, the area of that region, and also the area of that region. Now I need to be slightly careful because when I evaluate my definite integrals, I know that this area here, which I'll call region A, is going to end up as a negative answer. And this area here, which I'll call region B, is going to end up as a positive answer. So I'm going to need to evaluate each of those areas, find each of those areas separately, and then combine them. All right. Now, let's first of all concentrate on area A. Right, now area A, the area of that, well, I'm going to need to evaluate the definite integral between 0 and 1 of the function that I have here. Okay, so let's get on and do that. So before I start, let's multiply out these brackets. So now have x lots of, that's going to be x squared plus 2x minus 3. And now let's continue that process. So what I've got here is x cubed plus 2x squared minus 3x. So that is what I'm going to integrate now. So that's a quarter x to the power of 4 plus 2/3 x cubed minus 3 over 2 x squared. I don't need to worry about the constant term, and I'm evaluating that between the values of 0 and 1. All right, so let's stick in the value of 1 here. So that's going to be a quarter plus 2/3 minus 3 over 2. And from that, I need to subtract the value of the function when x is 0, which is just 0. So my answer there is minus 7/12. So the definite integral has a value of minus 7/12, but I have to remember that that means that area A is actually 7/12. Right, let's have a look now at area B. So to find area B, I'm going to have to evaluate the definite integral between 0 and minus 3. And again, I'm evaluating the definite integral of this function. So I've already done a lot of the legwork already. I can simply jump straight to the stage where I've already integrated the function. Just copying this down from the work I've already done. But this time I'm evaluating it between minus 3 and 0. Okay, right. So first of all, evaluate the function when x is 0, the higher of those values. So that's just 0. Subtract the value of the function when x is minus 3. So when x is minus 3, I'm going to get a quarter of 3 to the power 4. It doesn't matter about the sign in that case. Plus 2/3. X to the minus 3 cubed is minus 27. Okay. Minus 3 over 2 times by minus 3 squared is 9. So I'm going to need to carefully evaluate that. So I get 0 minus 45 quarters, which means that the value of my definite integral there is 45 quarters. So the area of this area here is 45 quarters, and the area of this area here was 7/12. So the total area of that finite region bounded by the curve and the x-axis is going to be 45 quarters plus 7/12, which is, on my calculator, 71/6. And that is example 11 done. Example 12. The diagram shows a sketch of part of a curve with that equation and the line with equation y equals x. Find the area of the region bounded by the curve and the line. So we're going to find the area of the yellow region there. Right, now, how are we going to do this? Well, what we're going to do is we're going to cut our graph off here. Okay. And we're going to find the area of this entire yellow region by finding the area under the curve between when x is 0 and x is whatever this is here. And then from that, we're going to subtract this area here, which we're going to find because it's the area, simply a triangle, so we can find the area of the triangle. So we're going to find the whole of that yellow region, and then we're going to subtract away the green region. All right. So we need to first of all find the whole of that yellow region. So what we need to know is what the value of x is here. So I'm going to take y equals x and also y equals x lots of 4 minus x and solve them simultaneously to find the x coordinate at that crossing point. So x will be x lots of 4 minus x. So x will be 4x minus x squared. So x squared, if I add x squared to both sides and also subtract an x from both sides, so that tells you that x is 3. So this value here is 3. All right, just drawing this button line again. So I'm going to find the area under the curve between the values of x is 0 and x is 3. I'm going to find the value of this definite integral. Okay, that's that yellow area. And from that, I'm going to subtract this area here, this green area. Now, that green area, what's it going to be? Well, I know it has a base of 3, and I know that this is the line y equals x, so that height must be 3 as well. So the area of that green triangle is 3 times 3 divided by 2, 4.5. So that is an expression for this area that I'm being asked to find. The whole of the yellow area, subtract that green triangle. So let's get on with it. Right, so 0 to 3, multiply out that bracket, gives me 4x minus x squared minus 4.5. Okay, I'm in a position to integrate now. 4x, that's going to be, the new power is 2, so 4 divided by 2, that's going to be 2x squared minus 1/3 x cubed. I'm evaluating that between 0 and 3, and from that I'm going to subtract 4.5. So I have got the value of that when x is 3, so that's going to be 2 times 9 minus 1/3 of 27. That's the expression when x is 3. From that, I'm going to subtract 0, the value of that expression when x is 0. And from the whole of that, I'm going to subtract 4.5. Right. So 2 nines are 18, minus 9. So that's going to be 9 minus 4.5, which gives me an answer of 4.5. So the area of the section I'm being asked to find is 4.5. And that is the end of example 12. Example 13. Right. We've got a sketch of the curve with this equation, okay, and also the line y equals 2x. And we're being asked to find that shaded yellow region. All right, so we need to make a plan. First thing to do is to make a plan, not just to do a whole load of maths without thinking about what you're doing. Now, if you want to find that shaded region, it seems to me that one way to do that would be to find the whole of this yellow region here, the whole of that triangle, and then from that triangle you could subtract away the area of this green region here, which is the area under the curve between this point and this point. So let's just backtrack a minute, okay, and break that down into steps. The first thing we're going to need to know is we're going to need to know the area of the triangle OCB. Now at present, I know that this is the point 0, 0. I don't know the base of the triangle, and I don't know the height of the triangle. But I reckon I can work that out, because I can work out the coordinates of the point here, which will tell me what I need to know. So let's work out the coordinates of that point there. All right. So that point is the point which at which y equals x lots of x minus 3 and y equals 2x cross. So I'm going to solve those two equations simultaneously. Okay. Squared minus 3x. I'm going to add 3x to both sides, gives me 5x equals x squared. So x equals 5. Right. So that point is the point 5, 10. Okay. Right, because y is 2x. Yes, that's right. So that's the point of 5, 0 there. And that's the point 10. That's y-axis is 10 there. Right, so now I think I'm in a position to find the area of the triangle OCB. The area of triangle OCB is going to be the base, 5 times the height, 10 divided by 2. So the area of that triangle is 25. Great. Okay. Right. Let's get rid of all this. Now, what I need to do now is I need to find the area under the curve here. This is the area I'm going to find now, and I'm going to subtract that away from the 25, from the area of the triangle I've just found. Right, how am I going to find that red shaded area? Well, clearly, I'm going to need to evaluate the definite integral of x lots of x minus 3, and I need to do that between where and where? Well, up to 5, because that's that point there, but I need to know that where that where the curve crosses the x-axis there, don't I? Well, I can work that out just by looking at the equation of the curve. Look, it crosses the x-axis at 0 and at 3. So this must be 3, 0, and I'm going to evaluate my definite integral between the values of 3 and 5. Okay, good. So let's get on with that then. So to do that, I'm going to multiply out this bracket. It's going to give me x squared minus 3x. So that's what I'm integrating. So that's going to be a third x cubed minus 3 over 2x squared. Don't need to worry about the constant term. And I'm evaluating that between 3 and 5. So let's put 5 in first. So it's a third times 125 minus 3 over 2 times 25. And from that, I'm going to subtract the value of the expression when x is 3. So that's a third times 27 minus 3 over 2 times 9. Okay, right. So I'm going to put that in my calculator. And that tells me that I get 26 over 3. So the area under the curve, which I've shaded in red on that top diagram, is 26 thirds. So my yellow area, therefore, the area that I'm asked for, the yellow area, is going to be the area of the triangle. Subtract the area under the curve between 3 and 5. Okay, which is going to give me whatever that is. Grab my calculator and work it out. 25 minus 26 thirds gives me an answer of 49 thirds. And that is the area of the shaded region found. And that's the end of example 13.